Welcome, my name is Efrain Gonzalez, and I'm gonna teach you guys about Newton's 3 laws. Hey there, young lady. Do you know about Newton's laws?
No, somewhat. I mean, I never really have anything to relate them to.
So you kind of forget?
Yeah.
Well, it's funny that you're dribbling a basketball, because I could give you a little lesson right now. And I'm not talking about in ball. I'm gonna teach you about Newton's first law. Heads up. You see that?
Yeah.
The ball's in motion, intended to stay in motion until your foot applied a force to stop it. That's Newton's first law. An object in motion will stay in motion unless an equal and opposite force acts upon it. Do you believe me?
Show me a little more.
This is what happens when your foot's not there.
Yeah.
Disregarding all the friction and the texture of the floor, the ball would have continued moving forever, infinity. But as you did see, it did last a lot longer, and when your foot wasn't on it,
Because there was nothing to stop it.
because there was nothing to stop it. Good
I
job.
get it. I get it.
Now on to Newton's second law. Drop it. See how high? You see how high it came back up when you dropped it? Now slam it down. That was well above my head. Do you know why?
No, why?
Newton's second law, force equals mass times acceleration. So, when you let it free fall, there wasn't much force acting on it besides gravity. So that's why it accelerated towards the ground and bounced up to only about right here. But when you applied the force of yourself and gravity,
Whoa.
it accelerated down and had a larger impact, in which it resulted over my head. That is Newton's second law. Alright. How about another example? Which one think is heavier? Which one think has more mass? The basketball? I'd agree. Which one think will hit the floor first?
This one, since it has more mass.
Since it has more mass, right? Let's watch. Did you see that?
Gosh, yes.
What just happened just now?
They both hit the floor at the same time.
Are you sure that's what you saw?
Yes?
Because it's true.
Oh.
Newton's second law states
Rick.
our last, but certainly not least, Newton's third law.
I totally forgot there was a third law.
Yeah, there's 3. Law of inertia, law of force equals mass times acceleration, and equal and opposite reaction forces. So, as you just seen, the starting position of this ball is right here, right?
Yes, sir.
I roll it, it hits the wall, and look where it stops. Disregarding friction and all that. It was remotely the same place, right? But why is that?
I'm not sure.
Newton's third law. For every action, there's an equal and opposite reaction. So the ball pushed on the wall, and the wall pushed back on the ball. Catch my drift?
Yeah, I could see where you're coming from.
So let's check your understanding. Look at yourself, right? Look at everyone around you. If the ground is pulling you down, why aren't you going through the floor?
Oh, I'm pulling up the ground.
Equal and opposite reaction forces.
Oh, I get it now.
Isn't it amazing? Newton's third law.
Wow, I get it now. Thanks for explaining it. All along, I played basketball for about 5 years now, and I never understood physics behind it.
Well, you learned physics, and you probably got even a better understanding of the game itself. You're welcome. Alright. So Newton's first law, often told as the law of inertia, is when one object is in motion, it's going to stay in motion. Oh! Out of here!
He's doing an honors project.
Hey there, young lady.
Hello.
Do you know about Newton's laws?
Not that much. I always seem to forget them. I don't really have anything to relate them to.
Well, it's funny you mention that because you're playing with a basketball. Do you play basketball?
No, only on my free time.
Well, here. Wait. On to Newton's first law. Heads up. See that? The ball was in motion and remained to stay in motion until her foot stopped it. Start all over.
Yeah, I could see where you're coming from.
So let's look at it again. Isn't it weird how the building didn't move, but the ball did? I don't know where I'm going with this. Let's look at another example. Yourself. Why are you not floating and why are you not in the ground?
I'm not sure.
Gravity. Newton's third law. Equal opposite reaction forces. Gravity pulls you to the floor. So you're on the floor, but you're also pulling back on gravity or the floor. So you're not floating.
No, that didn't make sense. That made no sense.
So let's check your understanding. Look at yourself, right? Look at everyone around you. If the ground is pulling you down, why aren't you going through the floor?
If the ground is pulling me
Oh
down?
my.
Okay, how that makes sense.
Look at it, look at it. The gravity's pulling down the ball, right?
Yes.
And the ball's pulling back up.
Alright. Alright.
get it.
No, I don't. But okay.
That is the bloopers. Nice.
Alright, whatever. I don't get this. Okay, Miss Klingler. I'm asking Miss Klingler. Right back. I'm pushing against the ground and the ground is pushing back up against me, like pushing me up. Let's answer that. Let's wait so you can answer my question. Let's see who's right, because I'm pretty sure I am. Leave that in the video. At the end. Bloopers or something.
Are you stopping?